We've been talking about solving systems of equations in various methods in class, and we've just basically been reminding us of stuff we've learned in Math 1. And so here we're going to be solving systems of equations, but this is different because it involves a quadratic. So we've also been solving systems of quadratic equations, or just regular quadratic equations. So this is a system involving a quadratic equation and a linear equation. And so we're just going to go ahead and solve it. So the first thing we're going to do is substitution and replace x with y. Well, x squared equals 2x plus 3. And we'll solve this, first of all, since it's quadratic, by setting it equal to 0. The first thing we're going to do is subtract 2x from both sides. At the same time, we'll also subtract 3 from both sides. And we will have this new equation, x squared minus 2x minus 3 equals 0. And this is the one we're going to solve. So what we hope is that it's factorable. I'm going to go ahead and try to factor it. We've got negative 3 and negative 2. And so the two numbers that multiply to make negative 3 but add to make negative 2 are negative 3 and positive 1, so it is factorable. And I've got x minus 3 times x plus 1 equals 0. So the other thing we want to consider is what else is happening with this. And the other thing that's happening here is that we can set each term equal to 0 separately, because that's what the zero product property says. If we multiply two things and we get 0, one of them has to be 0. So we'll solve this equation, x minus 3 equals 0, and we'll solve this equation, x plus 1 equals 0. And so x will be 3 or negative 1. Now, in previous times when we've solved systems, we've only ever gotten one answer at a time for x, but now we have two different answers, which means we're going to have to do more work here. So the next thing we're going to do is plug these in to see what happens. We'll start with 3, and we'll plug it into the first equation. We have y equals 3 squared, which is 9. So we think y is 9. To make sure we're right, we're going to plug into the second equation, and that says y equals 2 times 3 plus 3. So 6 plus 3, or 9. So y is 9. So it looks like that checks out, and so my ordered pair would be 3, 9 from the first problem. So we're pretty sure that's correct, and we'll call that one good. So that seems all well and fine, but let's see what happens with the negative 1. And so we have y equals, again, we'll plug into the first equation first, negative 1 squared, which is positive 1. So we think it's negative 1 comma positive 1, but let's check the other equation. We get y equals 2 times negative 1 plus 3. So we've got negative 2 plus 3, so y equals 1. So that seems to check out as well. And so my ordered pair here is negative 1 comma positive 1. And that seems very strange to have two different answers, because when we were solving systems before involving two linear equations, we always only had one answer because two lines crossed and met in an X shape, giving us one answer. So let's go ahead and head over to Desmos and see what is causing this strange phenomenon. So we'll use Desmos here. We have our first equation, y equals x squared. And then our second equation, y equals 2x. And that was, what was that? 2x plus 3. So, and then we have these two things. So what we see first off, just by looking at it, is we have this green curve representing x squared and this purple line, and they do meet twice. So if we click on this first intersection point, we find out that they meet first at negative 1, positive 1, which is one of our two answers. If we click on this intersection point, we see that they meet at 3, 9. And so those are the two answers we got, was 3, positive 9, and negative 1, negative 1, positive 1. So it seems that graphically that seems to have worked out just fine. And so we're able to verify with Desmos that this has worked great. So that's pretty awesome. And it's nice that the picture backs up the math we just did. So when we solve a system of equations involving a quadratic equation and a line, we should expect more than one answer, like we do with quadratics in general, where we always get two. We should get two different ordered pairs when we solve a system of equations with a quadratic. We'll talk more about this the next time I see you. Good luck with your sample problems.